I couldn't help but to notice that the Scienceless channel is gradually developing into a Scienceless community. The channel has at least 1,000 subscribers. Thank you so much to all our subscribers. My team and I are working on something for you. If you like our content and it's making a positive impact on your studies, please subscribe and press the notification button. Question 7 will examine financial mathematics. 7.1. Robinson deposited 8,500 into a savings account to purchase a new cell phone to be launched in 3 years' time. Now, what we have here in question 7 is that we have the principal amount, which can be understood to be the original amount that is deposited into a savings account or an investment. And we can see here that it will take 3 years until the phone is actually launched. So that means this money will probably be saved for a period of 3 years. Now the question continues under 7.1.1 to say, if the nominal interest rate is 15% per annum, compounded monthly, calculate the effective interest rate. Perhaps the first thing that you need to do here is to understand what is the nominal interest rate. Nominal interest rate can be defined as the money that is paid out on a loan, investment, or savings account more frequently than once in a year. This means that the money that you deposit will grow or say compound many times in a year. For example, it can grow daily, monthly, quarterly, or semi-annually. Now, if you look at our question, we are saying that this money grows every month. That means it will grow 12 times because we have 12 months in 1 year. And it grows at a rate of 15%. Now, this is to say here, we are given the number of times in which the money will grow in a year. So that is the time that will grow in a year. It will be 12 months. And our interest, nominal interest rate, will be given by I to the power m. M, as we said, is the number of times at which this money will grow. This means it will be I to the power 12. And we are saying that this would be 12, it will be 15%. Now, when we do our calculations, we don't like to write this money in percentages. Rather, we convert that to decimal. Now, to convert the percentage to decimal, we know that the percentage, it is out of 100%. That means I'm going to divide by 100. So that I have now 15 divided by 100, which is 0.15. Now, what is an effective interest rate? An effective interest rate is the annual interest rate. That means it is the money that is paid out on a loan, investment, or savings account per year. So this is the money that grows or it compounds every year. And usually we use just the symbol I because it only happens every year, once a year. Now, there is an equation that relates or allows us to convert nominal interest rate to effective interest rate and vice versa. This equation is really given by 1 plus I, which is the effective interest rate, is equals to, open bracket, 1 plus I to the power m, which is our nominal interest rate, divided by m, which is the time it takes for this money to grow, and to the power m. And from here, this question becomes a simple substitution problem where we're going to substitute the information that we have. So here I'm going to have a 1 plus 0.15. Remember, that's our percentage there. And we're saying this percentage grows or compounds 12 times in a year. Now, to solve this is relatively easy. I'm simply going to take the 1 and put it on the other side. So here I'm going to have a 15, 0.5 divided by 12 over 12, and then we're going to subtract 1. What I've done here, I've just taken the 1 to this side. And at this stage, this question becomes very, 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 very boring, because I'm simply just going to punch all these numbers on a calculator. And we actually get an amount of 0.160754, and it goes like that. Now, I'm not rounding off really at this stage, because this is not really my final answer. When you calculate interest rates, make sure that you write them in percentages. Now, to write this value in percentages, what I'm going to do really is that I'm going to multiply this by 100. And this would mean that we have an interest rate of 16.08%. Now remember, this is an interest rate that happens per year, that compounds every year, because an effective interest rate per the definition that I gave you. So this question will give you 2 marks, and what really they mark here is the fact that you used the correct formula and you had the correct substitution, and another mark for the final answer. Now the next question says to us 7.1.2, when the cell phone is launched at the end of 3 years, its value is 31,299. Will Robinson afford to purchase the cell phone? Justify your answer by means of appropriate calculations. Now, I would love to really break down this question using a number line so that we are able to visualize these payments and understand what's going on in this question. On our number line, we'll have the following structure. Now, here at the beginning of year 1, Robinson will deposit, he will put the 8,500 here. And this money will start gaining interest from the beginning of year 1 to the end of year 1. And the interest that it will gain, it will be the 16.08%, because we said that effective interest rate is an interest that accumulates per year. And the accumulated amount here will continue to stay in investment and from the beginning now of year 2 until the end of year 2, which will be somewhere here. Now again, during this time period, again, it will accumulate, it will grow, it will compound by the same rate that happens per annum. Now, at the end of year 2, that will be the beginning of year 3. It will stay again from the beginning of year 3 until the end of year 3. So this will be the beginning of year 3, and this will be the end of year 3. Now here at the end of year 3, that's where the money would have stayed for a period of 1, 2, 3 years in the savings account. So our N, or the number of years, will be the 3 years that we were given for the money to be invested there. But it's accumulating, or it's growing every year by a percentage of 16.08. Now, if you check this, we're saying this money is compounding every year. That means we are going to use the compound interest formula, which is given by A is equals to P 1 plus I to the power N. And we know that our principal amount, the original amount that was deposited, is 8,500. And here we're having 1 plus 0.160754, and it takes 3 years to be in the investment. And so this means at this stage I can use my calculator to say I really have 8,500, 1 plus 0.16 0.0754 to the power 3. And this means we are going to have 13,293.5.52. Now you must realize that when we get to the end of year 3, the phone has a price of 13,299. This is the price of the phone, the value that the phone cost when it's been launched. But we are saying that during this time period from year 1 to year 3, Robinson's money has grown to be 13,293. That means now Robinson won't be able to afford this money because the money that he has available at the end of year 3 is actually 13,295, which is less than the value of the phone. So here it means for us to answer the question, we will say here that Robinson will not afford the new phone since the accumulated amount at the end of 3 years is indeed less than the cost or the value of the phone. So we are saying here that the money that has accumulated in the savings account is less than the cost of the phone. So you won't be able to afford this phone. So this question here would be out of 3 marks. And really where we get our marks is from the fact that we actually use the correct formula. We are able to see the correct formula, correct substitution, and actually we have answered the question because the question wanted us to compare the two values that we have there. Moving along to question 7.2. Annie invested 6,000 at a rate of 7.25% per annum compounded annually at the beginning of each year. Fanny spends exactly the same amount of money each year on a business and forfeited it every year until the beginning of the 10th year when he made a net profit of 250,000. Between Annie and Fanny, who made the most money? Now, to understand this question and to break it down, we are going to use a number line again just to see what's happening in this question. So we are on 7.2. Now, on my number line, I will have the first year here, T1, where Annie deposits an amount of 6,000. This money is deposited, remember, at the beginning of each year. So let's say the first day is T1 there. Then we deposit here the 6,000. And if we go to year 2, Annie will deposit again a 6,000 into the savings account. And this continuous deposits will go on like that until say we get to some year here, T8. Again, here we'll have a deposit of 6,000. These are the same deposits really. And this can push on until we get also to year 9, where we deposit again the 6,000. And when we get to T10, the 10th year, the beginning of the 10th year, we'll again make a 6,000 deposit into the savings into this investment. Now notice that when we get to the beginning of the 10th year, this is where now you will see that Fanny has made the 250,000 in his business, because with Fanny, each and every time he deposited this money, he lost this money over the years until at this stage where he started making a net profit. Remember, a net profit would be the money that you make in a business after you have removed or reduced the expenses in your business. So this is the money that he has made, he has in his business. Now he has been losing money throughout those whole years. And at this time, Annie was depositing these amounts of money until we get to the beginning of that 10th year. Now, this is where we're going to stop making payments here, because we want to compare how much has the money that Annie has been putting up to this point has accumulated. And we want to compare that money with this money to see who between the two has made the most money. If you have this type of a structure where money is being deposited like this, we call this an annuity. An annuity simply means that we have regular investments of a set amount of money which earns compound interest. So what we're saying is that we have regular payments. We have payments that are being repeated over a certain amount of time. In this case, at the beginning of each year. And these amounts, they earn compound interest. And so that's why when you look at them here at the 10th year, at the beginning of the 10th year, they would have grown into a certain amount. But let us look at how each of these amounts actually grow every year. So for instance, if you look at the first payment that is being made here, this payment will stay in the account for a period of 9 years, because remember, it will stay from year 1, the beginning of year 1, and it will move on being in the account until the beginning of year 10. Now, it is very important to understand that this will be 9 years, because remember, we stop at the beginning of the 10th year. We don't go to the end of the 10th year. The easiest way to get the number of years in which this money would be in the account is to say 10 minus 1. That should give you a 9. So it means this money has stayed, has compounded, it has gained interest for a period of 9 years. Now, to represent this money, we are going to use the compound interest formula, where we say A is equals to P, open bracket 1 plus I to the power N. And I'm saying here we are depositing a 6,000 rand. We have 1 plus our interest will be 0.075. Remember, you are going to take this 7.25 and you divide by 100. And we are saying that this will stay for 9 years. The first deposit here, this 6,000 will stay for 9 years here. And I just want to simplify this and leave it at this point here, where I say I just want to add these two and say I have a 1.0.25 to the power 9. So now here we actually have a 6,000 1.075 to the power 9. This is the money that has stayed for 9 years into this account. Now, if you look at the second amount here, it will actually stay in the account from the beginning of year 2 until the beginning of year 10. That means that it will stay for a period of 8 years. Again, you can say 10 minus 2. It tells you the amount of time that this money has stayed. And if you look at the formula that I've constructed here, I still have the 6,000 deposited. It's going to be 1 plus the percentage. The compound interest is the same, because every year this money will compound at the same rate of 7.25 until we get to this year here. And in this case, the only thing that changes is the years, because this second payment, it will actually stay for 8 years in that account. So that means here we are going to have a 6,000 1.0725 to the power 8. And the third payment that will be made somewhere here, it will stay for 7 years. And this will continue like that until we get to the payment that will be made at the beginning of the 8th year here. And with this payment, you can see that it will also stay in this account from the beginning of the 8th year to the end of the 10th year. So that means this amount will stay only for 2 years, because you'll say here 10 minus 8, and that should give you a 2. So what I have here is a 6,000, 1.0725, but here I have a 2. I hope you see the pattern. So remember, with this one, we are saying it will stay in the account for a period of 8 years here. Now, I hope you can see the pattern here of what is going on. Remember, again, this amount that's here is going to be this amount here. We still have 1 plus, because we're using the formula of compound interest. It's compounding this money all the time, and it's compounding at the same rate. Each year, the money compounds at the same rate each year annually. Now, the only difference is that with this amount here, it's going to stay only for 2 years in the account. And if we do the same for the beginning of the deposit of the money that is made at the beginning of the 10th year, you will see that this money here will stay for 6,000, and I'm going to have here open bracket 1.0725, but it will only stay for a year, because we're depositing this money here until it gets to this point here. So this money here, the last money is deposited at the beginning of the 9th year to the end of the 10th year. It earns interest only for 1 year. But there is a last payment that has been made here of 6,000. This last payment is deposited at the beginning of the 10th year, and that's where we want to compare. That's where we stop making payments. So it means this money here at the last year doesn't earn interest. It doesn't stay for a year to earn interest, because we stop here. So it means Annie will make a payment, and immediately at that stage, you want to compare the amount of money that she has deposited in the account to see how much it has accumulated. So it means at this part, we only have 6,000, which doesn't earn interest, because it really stays immediately after depositing. We want to see how much it is. With this arrangement that I have here now, I'm going to then reverse things and actually start arranging these amounts from this side going backwards there to see how much this money has accumulated over time. So what I'm going to do is that I'm going to say that we have a 6,000 here. So we have a 6,000, which doesn't earn interest, and I'm adding that, because remember, I just want to find the total amount of money there. So I'm just adding all these amounts, but I'm going to add them in the reverse way. I'm going to start here and add backwards. I'll get the same answer really, even if I can start here and add in that direction. But I want to show you something very special when you add the money backwards. So I'm going to add the 6,000. After adding that, I'm going to add this one here. So I'm going to have a 6,000, 1.0725 to the power 1 there. Then we're going to continue to then add the 6,000, 1.0725, and then we have a 2 here. Remember, it's this amount here. And we are going to continue adding this money like that until we get, let's say, to the final payment, which is this one here. And it's going, the first, which used to be the first payment, I mean to say. So it means you're going to have a 6,000, 1.0725, and here we're saying 9. Now notice that even if we end here at 9, we have actually made 10 payments, because the last payment here is also included. So that means we have a total of 10 payments. Now when you look at these numbers, when they're sitting like this, to me they look like a geometric series. It's like I'm adding the terms of a geometric series, where the first term is going to be A is equals to 6,000. This is our first term here. And if you notice, what we are doing here really is that we are multiplying here by 1.0725. If I multiply this number by that, I'm getting this number here. And for a geometric series, I need to multiply by the constant ratio. It means I'm going to multiply again here by the same value of 0.0725. Look at this. If you multiply this by that, these ones will keep the base and add the exponent. We'll have 2 here. That's what we get we get there. And if you continue doing like that, you can see that we have a constant common ratio. So it means here our R will be equals to 1.0725. And basically it means I can use the formula of the sum of a geometric series, because this is a geometric series. I'm adding terms of a geometric series. If I add all these amounts here, they will tell me the money that Annie has made in the past 10 payments, or in the past 10 years, if you like to put it that way. Our formula we know of a geometric series that is given by Sn is equals to A open bracket R to the power n minus 1 all over R minus 1. And we are saying here that our first term is a 6,000. Our ratio really is 1.0725. And you know, this happens 10 times, meaning we're having 10 terms, or we're making 10 payments over a period of 10 years. And we also now subtracting here by a 1, and this is divided by 1.0725 minus 1. And from here, this question becomes very, 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 very boring, because we're just going to pull our calculator here and see that we have a 6,000. Then we have a 1.0725 to the power 10. I'm subtracting 1 here all over 1.0725. And this gives me an amount of 884.06. Now, if we compare the answer that we got to the money that Fanny has made, because remember, we want to see who between the two has made the most money. So it means Fanny on his business has made the most money, because he was able to make 250 over the last 10 years. But Annie, his money actually accumulated in the investment to be 83,000. So that's how you are going to answer your question, to say Fanny has made the most money because he made 250,000 and Annie only made 83,000. Now, I want to share with you another method in which this question can be tackled. And this is very important for me to do, because I just want to explore options that, you know, can work for you. I know some people will prefer a method where they are comfortable with using the sequence and series method, and some people are really comfortable using the equation of the future value. There is an equation of a future value which is there on a formula sheet that says the future value is given by x square brackets, then we have a small bracket there where we say 1 minus I to the power n minus 1, and we say this is all over I. Obviously the I here is our interest rate. Remember, this is like more like an effective interest rate, because it's the interest rate that accumulates or compounds annually, meaning per year, every year. Now the x here represents the amount that you make each and every year, or at regular intervals, because in this specific question we are having the amount that is made at regular intervals that are at the beginning of every year. So this is the money that you put at the beginning of every year. So that is your x there. And obviously we know that this is 10 years. Now there's something very interesting that I want to show you. If you use this equation and you say we're depositing 6,000 at the beginning of each year, and we're having 1 minus, here we're going to have a 0.0725. Remember, if you divide this interest by 100, you should get that 0.725. And here we're saying these payments, we make 10 payments, or they're made over a period of 10 years. And then we're subtracting by a 1 here, and we're dividing this by the interest of 0.0725. Now, I will stop here. I won't do the final answer, but you should get the same value that we got here. But I want to show you something very interesting. If you look at the substitution that we made here and the substitution that we made here, they're exactly the same really, because here I have a 6,000, I also have a 6,000. Inside the brackets here, I have a 1 plus 0.725. Look at this, I have 1 here plus, so I made a mistake on my equation, it should be 1 plus 0.0725. You know, if you add these two, you should get this amount. And we do have negative 1 there, we have negative 1. At the bottom, I have 1.0725 minus 1. So if you look at this number here, we actually subtracted 1 already because you only have the interest. If you subtract 1 here, you should get this number here. So these two equations, they really look the same and they should give you the same answer. It just depends on which one you feel comfortable to use. Now, this question is really marked out of 4 marks. And what really they mark here is the fact that you used the correct formula, you did the correct substitution, and then you got that answer. But remember, you have to answer your question in words to say here, Fanny has made the most money than Annie, because you know the money that Fanny, the net profit that Fanny has is 250,000, and the money that Annie has accumulated over that 10-year period of time is actually 83,000. So that statement, when you write it down, it will give you another mark for 4 marks. The last question, which is question 7.3, looks at sinking funds. I have a strong feeling that this year you'll get a question that requires you to do a sinking fund calculations. And this is because of, in the past 10 years or so, this question has never came up in your exams. So I feel like this year you should be ready and prepared to do sinking funds calculations. Now, the question reads as follows. It says that the Scienceless channel owns a drum scanner which needs to be replaced with a newer model in 5 years' time. The cost of the new machine is estimated to be 350,000. How much should the Scienceless channel deposit each month into a sinking fund to accumulate enough money to replace the old scanner? The sinking fund pays an annual rate of 8.4% compounded semi-annually. There is a couple of steps that you have to follow. The first step that we're going to do here is to calculate the depreciation of this machine, of this scanner that we have. And to get that depreciation, we are going to then take our principal amount to be 350,000, because this is the cost of the new machine. It costs this much. So we want to see that in a period of 5 years, how much will it have depreciated? How much would it have lost value? So that's what we're going to do. But you know, there's a couple of interesting things that we have to look at here. Our interest here, we're saying that it is 8.4%, and obviously, you know, we're going to divide this by 100 so that we get the 0.084%. But we're saying that this interest is compounded semi-annually, meaning every 6 months in a year. So it compounds twice in a year. So that's why we're going to divide this by a 2, because it compounds twice every year. And if you divide this 0.084 by a 2, you should get here a 0.042. Now, if we look at the number of years here, this money will be put, or the machine has to be replaced after 5 years. So that means if we were to save this money, it should stay for 5 years in our investment for a sinking fund. Now, you have to realize that in that 5 years, the money compounds twice, as I said. It will be compounding every 6 months. So it means each year the money will grow twice. So that means here the 5 year we're going to multiply by a 2 and it will give us 10. So every year it grows twice, and in 5 years time it should be 10 times. Now this here we are going to use the reducing balance depreciation. Let me write this down. And reducing balance is really given by A is equals to P 1 plus 1 minus. Remember here now it's a subtraction, 1 minus, and because it's losing value. And we're saying the machine cost 350,000. 1 plus the interest, we said it is 0.042, and it occurs 10 times. And this should give us a value of 350,000. Our machine would have depreciated to a value of 275 after the period of 5 years. So this is 227,888.8. Maybe let me not round off this because it's not the final answer. Now that's the first step. You find the depreciation of this machine. You want to see by how much it will have lost its price in a given period of time. Now, after doing that, you then look at how much it will have accumulated in the same amount of time. So you look at how much the machine would have gained value in that period of time. So this means I'm going to use the compound interest formula, right? So here we're going to use the compound interest. So the compound interest is exactly the opposite of what we've done there at the top. Is 1 plus n to the power n. Now look at this. The reason we're using compound interest is because of this money is compounding. So now here we're going to have the 350. We want to see by how much it will grow in that given time period. So this will be 1 plus the 0.042, and this occurs for 10 years as well. So on my equation here, I'm going to have a plus here. So it means the machine in the next 5 years, it will cost almost above 500,000. So again, here I'm going to round off. I'm not going to round off this answer. I'm going to leave it like that. Now remember, with depreciation, we have two types of depreciation. We have a straight line depreciation and also reducing balance. I've used reducing balance here because our interest is a compound interest. It's compounding, and it's not on a straight line basis. So sometimes they won't tell you directly. So you have to be able to see which one you use when you read the statement. Now, when you have calculated these two, you then calculate your sinking fund. The question would be, what is a sinking fund? A sinking fund is money that is put aside for a particular purpose and is invested so that the correct amount of money will be available when it's needed in the future. So for instance, this would be the money that we put aside today so that in future we can replace the machine that we want to buy. So that's what the sinking fund is basically. And how you then calculate that, or how you find that, you compare how the machine is reducing its value using the current value of 350 in this case to how much it will cost in that in future in the future time of 5 years in this case in our example. Now the difference between the two, they give you a sinking fund. In other words, if I say here the 528,135.3459 minus that 227,888.806, the money that I get here is the sinking fund. It compares how the machine is losing value and how it will gain value. So the difference between the two will tell me the sinking fund of that machine. Now when we then do this calculation, we're going to have here a 528,135.3459 minus 227,888.8806, and this says that the machine will have a sinking fund of 300,246.4653. The question requires us to find the monthly payments to say, okay, if the machine will cost this amount, how much should we put in our bank account every month so that by the time 5 years arrives, we are able to purchase that machine at this amount. So this means now I can use a future value equation where I say the future value of this machine will be given by x 1 plus I to the power n minus 1 all over I. And then what we are going to look for here is the payments that we have to make every month. For us to reach this amount in future, because we know that this will be the future amount of the machine. So now this means here now I'm going to have 300,000 246.4653, and this is equals to x, and then I'm going to have here 1 plus 0.042 to the power 10 minus 1, and this is all divided by that interest. And to get this value, really, it's easy. We just simply going here to cross multiply this number here so that I'm having this times that, and to remove this part here that's left at the top here, I'm going to divide by the same amount so that it comes this side, and I can find my x. So really here I'm just going to do everything on my calculator. 3,246.4653 multiplied by 0.042, and we're dividing all this by 1 plus 0.042 close bracket to the power 10 minus 1. And this says that we have to pay an amount of 24,776.80 every month for us to be able to afford this machine at 3,000 in 5 years' time. Now this question will be marked out of 5 marks. So you would see that, these two equations, because, we've been using them a couple of times, will only give you 1 mark for getting the correct answer there. And you'll get a mark for getting the sinking fund. And here you'll get a mark for substitution and 1 mark for the final answer. And that should give you a total of 5